For hundreds of years, physicists have been developing theories to describe the world around us. Our current best theory, known as the Standard Model, can explain just about everything we see, from subatomic particles to the formation of stars. But there's a problem. According to the Standard Model, we shouldn't be here. In fact, it says that the entire universe should be empty. Now, obviously, the universe isn't empty, and the goal of my experiment is to help us understand why, so we can bridge this gap between theory and reality. The problem arises from the fact that energy can spontaneously turn into matter and antimatter. We're all familiar with matter, but what you may not know is that matter has a twin. Just like identical twins, antimatter can do anything that matter can do. If I replaced all the matter on Earth with antimatter, none of us would be able to tell the difference. That's because they behave the same way and are interchangeable. But these twins really don't get along. If they get too close, they annihilate, both disappearing and turning into pure energy. So the problem with the Standard Model is this. The universe began with the Big Bang, a tremendous flash of energy. This should have made the same amount of matter and antimatter. And in the billions of years since, the twins should have completely collided and turned back into energy, leaving the universe a dark and empty place. Knowing the Standard Model must be flawed, physicists propose new theories where energy makes more matter than antimatter. Then, after the Big Bang, when the twins collide, there's matter left over to form our universe. We think one of these new theories must be right, but we need evidence to show it. So let's focus on the red twin, matter. In these new theories, energy ends up making matter, but in the Standard Model, it doesn't. So matter on the left and right sides of the screen must be different. This difference would show up in atoms, the building blocks of matter. According to the Standard Model, the positively charged nuclei at the center of atoms are perfectly round. But these new theories predict that nuclei have more charge on one side than the other. The goal of my experiment is to measure whether or not this asymmetry exists. If it does, it's an incredibly small effect. Nuclei are more than 1 billion times smaller than the width of a human hair. And if you imagine them to be the size of the Earth, we're looking for at most a single golf ball of charge out of place. But if we can find and measure the size of this tiny asymmetry, it could help us figure out which of these new theories is correct. Then we might finally be able to explain how the universe was filled with the red twin, matter, and understand how we got here over 13 billion years after the Big Bang.